Good morning, viewer. Welcome to our Glory Globe TV's really amazing news for viewer. Researchers take the first steps towards recreating powerful chemicals derived from plants in the laboratory. For the same, Olsman and Laxfluor can cause neurotoxicity and paralysis at extremely low doses. Yet their chemistry has also been used against pain, malaria, cancer, and pests. Researchers have now taken the first steps towards recreating some of these powerful plant compounds in the laboratory, opening a potential route to testing and developing naturally derived treatment. Yeah, the work brought together scientists at Michigan State University and the Czech Academy of Sciences, and their findings focused on Olsban and Laxfluor are published in Molecular Plant. Viewers, these plants have been used in different forms of medicines throughout the world of thousands of years, said MSU Alu Garrett Miller, co-first author of the paper, are now an assistant professor of biotechnology at the University of Michigan Plain. We know they interact with our bodies in so many ways, and understanding how to create them can help provide totally new routes of testing. Even after centuries of specific progress, reproducing the chemical complexity of plants remains difficult. So, plants are the best chemicals around, upgrading their arsenal of natural compounds over millions of years to help them survive, said Zron Hamburger, study author, and James K. Billiman, endowed professor at MSU's Department of Biochemistry and Molecular Biology. Viewers, humans have found countless uses for these molecules in everyday life, added Lana Mutsa, a graduate student at the Czech Academy of Sciences and co-first author of the latest paper. These include caffeine, capsaicin, menthol, and vanillin, not to mention the fact that many of the medicines we use today either come directly from plants or are inspired by plant chemistry. Hamburger's laboratory at MSU studies these compounds known as specialized metabolites and explores how their chemistry might be put to practical use. Viewers, in recent years, the researchers turned their attention to Laxfluor, which is also called delphinium, because of its dolphin-shaped flowers. They wanted to determine how the plant produces diterpenoid alkaloids, a group of chemicals that are both highly toxic and medically promising. The challenge was considerable. Diterpenoid alkaloids combine features from two of the oldest and largest groups of plant chemicals, giving them exceptionally complicated molecular structure. Aconitine, one of the best known examples, was isolated almost 200 years ago. For the same, scientists have still not succeeded in synthesizing in laboratory. The project gained momentum through an unexpected meeting. At a research conference in Barcelona, Hamburger encountered scientists from Thomas Pascal's laboratory at the Czech Academy of Sciences. Mustafa Zia and other members of the Pascal group were investigating the same difficult class of compounds in Olsvani, also known as moxoot, a notoriously poisonous relative of Laxfluor. When this happens, we can either go our own ways too, or come together. And it is joining up that always leads to the best science, said Hamburger. After joining forces, the researchers set out to identify the exact biochemical pathway that Olsven and Laxfluor used to make diterpenoid alkaloids. They computed several species and examined thousands of genes, looking for those that became active in the right plant tissues at the right stage of compound production. Then the exclusive report.